If you want to check the accuracy of the assembly, go for the sectional view, make it normal. Okay. So like this, the curved part of the shaft and curved part of the disc should match like this. Okay. If your all dimensions are correct, if you have drawn the curve correct, you'll be able to get this assembly. So this is the final assembly. So if you want to verify this, this is the final drawing. The same drawing we have generated in the SolidWorks. So this is the assembly of the footstep bearing. Okay, now next we will move on for drawing the drawing sheet. So save this assembly. Assembly of footstep bearing. Like this, we'll able to get this assembly. Now we will save this and then go for the drawing sheet. File. Okay. Yes, I told last time also you can create your own A3 size template. Here I will choose A3 ISO. So if you want to make the changes in this existing sheet, you can make by clicking the sheet format. Now you can make the changes. Once you made the changes, this will become again deactive. Okay. So in assembly, we insert the part for to get different views. So before that, you must exit from the sheet. Okay. Now I have exited from this sheet. I will go to the model view, browse. So this is my assembly drawing. This one. This is going to be the first view. Okay. This is going to be the second view. This is the view. This is the view. And this. So you can click multiple times to select which type of view you want. Now these are the views are enough. So this is bottom view. I don't want this one. So you can draw this top view first. And then if you observe this side view is there, we'll keep the side view as it is and we'll draw sectional front view. Okay. Now if you compare these three isometric view, this view is easily this and this view is easily visible. So I'll keep this one will be deleted. And you can add annotation. So before adding annotation, we have to make some changes like the scaling. Now scale is 1:2. You can increase to the custom scale, user defined. So this will become a little bit enlarged. Now next thing is that make the hidden lines visible. So for these three views we need hidden lines. So I did this much correction in the drawing well done. Now next thing is that make the hidden lines off for this. The next thing is to draw a sectional view. Okay. So to draw a sectional view, I will choose this side view so that I will get a full sectional view like this. Okay. So I don't want this front view. I will delete this front view and replace this front view with a sectional front. Okay. So any detail view if you want, you can draw here. So I will draw a detail view of this surface. Here. So these things must be verified. This pinhole, size of the pinhole in this curve matching. This is the detail view. It is a critical diagram for them. Next part is, okay, I think views part is over. Next part we are going for annotation. So in annotation we have to give the dimensions. The dimensions you can give manually also or auto dimension also. So if I am using auto dimension option for selected entities, if I make it okay, I will get dimension for the selected view. Whichever dimensions I don't want, I can delete it. In this dimension, we have to arrange all the entities properly so that it should not obstruct the view of the drawing. It should give some information about the drawing, but it should not avoid the view. This much is not required, this thing is not required, this thing is not required. This is required, it is made. Since the radius dimension is not required. These dimensions are taken automatically through auto dimension. Some dimensions you can mention by yourself, like the distance between this line and this line is 200. So you can mention here the distance between this line and this line is 130. Okay. These things are visible only in top view. Distance between, okay, center is not visible. We have to take point to take a dimension, but it is not. Another thing is we have to define the dimensions of this pinhole in diameter. Also the dimension of this, so it's okay. There's no need to, you can define in this view the slot dimension. Distance between these other lenses. Okay, so this is about giving the dimension. Similarly, you can draw the dimensions for all these views, front view and top view. You can define height of the shaft, all these things. So all the dimensions are mentioned in the part dimension. All the dimensions should be visible on this drawing. Okay. So it will show that we have used all the dimensions given. Okay. And next thing is giving the balloon or giving the part number. So part number is, you have to give part number one by one. This is one part. This is one part. This is one part. This is one part. Okay, so I think all the one to third part is left. The third part is this. And all the parts must be given number. Part number to be there. Okay, I will make this view as change. I will change the scale to 1:2. That it will be a little bit reduced in size. since I want to enter the part list table, I'm trying to make some space. So it is your job, whenever any drawing is given, you have to adjust the space according to your requirement. Okay. One more thing is left is a note. A note, we have to enter the name of each view. So this is sectional front view. Like this, we have to enter the name of each and every view. Okay. The next is to enter the part list table. So bill of materials, you have to select any view first. Okay. So this view is selected, click OK. Now this change. So all the parts are listed here. The only thing we have to add the material by clicking keep key. So the material of the body is cast iron. So write it in full. Don't use shortcut in the part list. So cast iron. Like this, you can enter all the material details. So this is about generating the drawing sheet of footstep assembly of a footstep bearing. Okay, you can create own title box, own title. Okay, so like this, you can enter the name also. Okay, so this much is about assembly of footstep bearing. Okay, so we will move for the next experiment in the next tutorial. Thank you.